Unit 7, Part 2. Let's begin on Section 1 of Unit 7 on form and substitution instance. This is a very crucial section, and it's very important to get very clear on the teaching of this section. If you recall from the very beginning, our definition of validity refers to the notion of a substitution instance, right? Our definition of validity involved the concept of a substitution instance, right? And it involves a relation between form and substitution instance, which we are only going to get rigorous about here in Section 1 of Unit 7. Even though much of what it says I've sort of brought in previous lectures, but recall our definition of validity. An argument, a particular argument, is valid if and only if its form is valid, right? So the its form is already conceiving of the particular argument as a substitution instance of that form, right? A particular argument is valid if and only if its form is valid, and its form is valid if and only if that form has no substitution instances where the premises are all true and the conclusion is false. That's what a counterexample is, okay? So that definition of validity has the notion of form and substitution instance in it. Getting clear on that now in Unit 7 as we commence on proofs, on how to do proofs, it's most crucial to get very clear on it here, precisely because all the rules which we use in doing proofs, right? Much of the work of learning how to do proofs is getting familiar with the rules, not only learning what they are in the abstract, but very much learning how to apply them in to see the form in the instances, as I'll say many times in the lectures on this part. All the rules were given throughout Unit 7, Unit 8, Unit 9. They're all presented as argument forms. They all are valid argument forms. That they are valid argument forms, you can convince yourself, given what you already know, by using the truth table test to draw up a full truth table for each of the argument forms and inspect to see if there's any counterexamples. And you'll discover for every single rule that there are no counterexamples for any of the rules. They are all valid argument forms. They are all truth preserving, right? It is the case, say for the rules of inference of Unit 7, that the premises do logically imply the conclusion. And you recall what logical implication means from Unit 6, right? There's no instance of the first being true and the second being false, right? The rules are all truth preserving, which is as it should be, because right, these are rules for proofs. We want them to be. We've only chosen as part of our system truth preserving rules, valid rules, but you can convince yourself by doing the truth tables. So all the rules that we have, right, for example, the first one you're introduced to is Modus Ponens. So now I'm going to say why it's so very crucial for you to be able to handle this section on proofs, to be very clear on the difference between form and substitution instance, be very clear on the relation between them. All the forms are presented as, all the rules are presented as argument forms where the atoms, right, the basic elements are what I've always been calling sentential variables. In this unit, Klenk refers to them as both sentential variables and statement variables. The definitions are given of statement variables. Those two terms are synonymous. So if I say sentential variables and you're thinking statement variables, they're the same thing, synonymous terms, right? All the forms are given in terms of where the atoms are statement variables or sentence variables, right? But most of the proofs you'll be doing throughout the exercises and also in the exam will be in terms of particular arguments where the atoms are not statement variables, but rather statement constants, right? Statement constants. Remember, as I've said several times, A and B and C, capital letters, A, B, C, D, E, F, G, all these capital or uppercase letters, these are not variables, right? These are statement constants, they each refer to particular English sentences, right? They're abbreviations of particular English sentence. A means something like Dan is Australian, right? Particular English sentence. And of course the crucial difference there, as I've said several times, these things, A, B, G, right, these statement constants have truth values. They are all either true or false. That is not true of the sentence variables P and Q. They are variables, not themselves true or false. Klenk calls them meaningless sometimes. Now, it's very crucial to grasp that the forms, right, that the forms, very crucial to be aware that the forms are presented with sentence variables, because what are sentence variables? Sentence variables are things which are capable of taking as substitution instances formulas of any complexity, either simple formulas or complex ones, right? That's why it's so crucial, as I've been stressing throughout the first part of the course, to be able to read all these rules, to express all these rules in a way like this, right? Read this rule not merely as telling you if P then Q and if P then Q and P then Q, not just if I'm given P and Q and I'm given P, I can infer Q. You have to say it like this, right? Given any conditional, and given the antecedent of the conditional, I'm entitled to infer the consequent of the conditional, right? So be very careful, be attentive to, when you're reading through Klenk and you're reading all the rules, the description of the rules, the verbal descriptions of the rules she gives. For example, in Modus Ponens, right, that'll be exactly what I just said, I think, right? So Modus Ponens is down the bottom here, and focus, right? So what does it say? Given a conditional and the antecedent of the conditional, you are permitted to infer the consequent of the conditional. And Modus Tollens on the next page, you'll see, right? See what it says there, right? That's the verbal description. You have to understand the rules like that. Given a conditional and the negation of the consequent of the conditional, you are permitted to infer the negation of the antecedent of the conditional, right? Or hypothetical syllogism on the next page, right? Page 122 now. There's that. Understand hypothetical syllogism this way, right? Given two conditionals in which the consequent of the first is identical to the antecedent of the second, you may infer the conditional whose antecedent is the antecedent of the first and whose consequent is the consequent of the second. Now, that's quite wordy, but you have to be able to understand it that way. To understand it in its full generality, right? Because, right, this means, right, my stress is on the word any, right? The P's and the Q's as sentence variables or statement variables can take as substitution instances any formula of whatever length, right? So you can have big, long, ugly, complex formulas. So long as you have, so long as the major operator of that formula is a conditional, that formula is a conditional. And you have to see the form of that thing, right? You have to see that big, long, ugly thing and say, it is a conditional. And then maybe you have another premise in your proof. If you're given a proof, a list of premises, asked to derive some conclusion, you may also have the big, long, ugly thing, less long, less ugly, but the big, long, ugly thing, which is the antecedent of that conditional, right? You need to be able to see, in a situation like that, this rule waiting to happen, right? You need to see the forms in the instances, right? It's very Platonic, okay? So for example, here, right? So imagine this is a proof, right? You've got these two premises. They might be separated. You might have 7 or 8 other premises between these two. But when you're scanning the proof, it's all, as I'll be stressing, learning to do proofs, coming to do them well, knowing how to go on with doing a proof. It's all about where your eyes go, about what you're attending to, what you're seeing or thinking when you're looking at the premises and thinking of how to proceed, and having the right thoughts in the right order, right? That'll become more concrete as I go through examples and show you what I'm talking about. But for example, to start off, you need to look at this, okay? So this, look at these two formulas. What do you see in these formulas? So the first is a conditional, it's true. So you're thinking, why is he teaching me this? He's going to be teaching me this, that he's going to be, and I am going to be making the conclusion that these two formulas are an application of modus ponens waiting to happen, right? You'll need to be able to see this and perform the proof and perform an application of modus ponens. Also, this is going to be the conditional, right? Because this is a conditional. Not in this case, right? If you look at these two formulas, what do you see? Right? You've got, oh, there's a certain identity between that and that. Those are the same things. But look at this. This is a conditional. So certainly look at 2. Right? Step 2. This is a conditional, right? So I'm given a conditional, and now the first premise is actually the antecedent of the conditional. So it's not the case, it's not that this is a substitution of P hook Q. So notice this. This is of the form P hook Q because it is a conditional, and every conditional is of the form P hook Q. I'll be doing the exercises, exercise 1, to show you how to recognize when individual statements are or are not instances of forms. Right? But this is an instance of P or Q, but this is also an instance of P in this case. And in this case, I'm going to substitute P for this, and this is my P hook Q, right? So I need to see this as P hook Q, right? That is to say, so see how I will see it if I am saying the rule, the form, in its full generality, right? What does it say? Given any conditional and the antecedent of that conditional, you're entitled to infer the consequent of the conditional, right? Also notice another lesson's being taught here, which is that the order that they appear does not matter. Klenk makes this point explicitly, I think quite late in the chapter, but it's true, right? It can be P and P or Q as it is here, and the rule does apply. Order doesn't matter, right? So this is a conditional and the antecedent of the conditional. You have to be able to see the form in this instance, right? See this is an instance, right? So that's ready to go such that you are able to use this rule. What does the rule say? Given a conditional, given the antecedent of the conditional, you're entitled to infer the consequent. I'm entitled to say G, right? Oh, sorry, that wasn't right. That's supposed to be B. That's supposed to be B. Otherwise it's not identical. Well done if you notice it wasn't identical, but say they're identical. Now they are identical, that's what it was supposed to be. Right. Infer G by modus ponens, steps 1,